Okay, good afternoon again, everybody. So before we begin, may I recognize Chazelle to make an announcement? Go, Chazelle.
Good afternoon po. I am Jazeline Casanova, and on behalf of AMAT 199 Section T, under the supervision of Associate Professor Arely Domingo, I would like to invite all of you to our upcoming webinar event with the theme Past, Present, and Future, The Old Script Meets the New Technology. This webinar will happen on Monday, 15th of November 2021, 9 o'clock a.m. via Zoom and Facebook Live. Our guest speaker, Mr. Rodney Pino from the University of Philippines Diliman and Baguio, will discuss their study entitled Optical Character Recognition System for Bibyne Scripts using Support Vector Machine. If you're interested, you can pre-register using the link that you can find on our Facebook page. Certificates of participation will be distributed to the participants if they answer the evaluation form. Also, Sir Neil will be giving incentives if you attend the webinar and also pass the necessary requirements he will require. For more updates, you can check our official Facebook page, AMAT199-seminars. And if you have other concerns, you can also send a message on our Facebook page or send us an email at amat199.externals@gmail.com or amat199.records@gmail.com. Thank you so much, and together let us unveil the relationship of the past, present, and future. Thank you po, sir.
Okay, thank you, Chazelle. So if you guys are interested with the topic, so you can join their webinar, and kailan nga to? November 15, if I'm not mistaken. So if you attend it, I'll just request you to submit a short reaction paper. Walang page limit. You can be as short as, say, one or two paragraphs, or it can be as long. It could be as long as a couple of pages. Para lang malaman ko what are the things that you gained from this webinar. Okay. So I'll be giving a little incentive to those who will attend and submit a reaction paper or a short exposition of what you got from the seminar. I'll open a submission bin in Canvas for that. So just visit their Facebook page or send an email to their address for some details. Okay. So another housekeeping matter. Finally, last Tuesday, I got the permission of a majority of the class to increase the number of problem sets for this course. So instead of three, we will have four problem sets. So in-adjust ko na yung standings nyo sa Canvas. So each of the problem sets will be worth 15%. So nung in-adjust ko yung computations, some of you got higher scores. The average standing now for the course is about 97%. So great, guys. Hopefully you can keep it up until the end of the semester. But I do understand the worry of some of you. There's also a significant number who voted no. Pero yeah, I think it's about the volume of requirements that you will need to submit. So what? Don't worry. To minimize the number of works that you need to submit for the course, I'll be sticking to the 3-5 format. So meaning for those two remaining problem sets, I'll give you 5 questions, but you'll need to answer only three. Okay. So I'll give 5 questions. One of them will be a required submission, and then you can pick two out of the remaining four kung alin doon yung sasagutan nyo. So para medyo mabawasan man lang yung kailangan yung isubmit. Okay, because I do understand why others prefer to have only three problem sets. And actually, I propose it para hindi rin matambakan sa dulo. Kasi kung isa na lang yung problem set, kailangan kong isama dun sa huling problem set yung buong coverage na i-discuss natin after the reading break. And that might spell some trouble for you kasi mapipilitan akong dagdagan yung number of questions. But I hope that's a good compromise. I'll stick to the 3-5 format, and maybe we can schedule the third problem sets probably after we discuss a good portion of unit 4, which is derivatives. I'm going to inform you guys a couple of weeks before the deadline of the third problem set kung kailan talaga yung schedule niya. Okay? Now, let's go to our actual topic for this afternoon. We'll be continuing our discussion about the sequential criterion for functional limits, and if time allows, we will also look at briefly ano yung one-sided limits na kinoconsider natin, which is another extension of what we learned from Math 36, and then hopefully that will prepare us for a discussion of continuity, pero in a more general sense than what we have encountered in Math 36. Okay, I think last time we started characterizing or describing what Theorem 3.1 is giving us. So this gives us an alternative characterization of the limit of a function. So sabi natin, isang pinagkaiba ng definition natin mula sa definition ng Math 36 ay ang requirement natin sa mga functions kung saan natin i-define yung konsepto ng limit, dapat define sila sa isang arbitrary subset ni R. Okay? So it would be a map that takes elements of an arbitrary set A towards the set of real numbers, so real valued yung mga functions natin. We don't require A to be an open interval, unlike what was required in Math 36. And then the requirement is the constant to which we will compute the limit at, dapat ay isang limit point nung set A. All right? So sa Math 36, sabi natin, let f be a function defined in some open interval containing containing x sub 0 except possibly at x sub 0. So understood na dapat defined sa open interval. Pero dito, hindi kailangan na magkaroon tayo ng open interval kung saan naka-define yung function f. Dapat lamang ay meron kang set kung saan define si function f na limit point ng set na yon si x sub 0. And if that happens, then we will go through the usual epsilon delta characterization of the limit. For every challenge epsilon greater than 0, there should exist a response delta greater than 0, preferably small enough, so that whenever x minus a is strictly between, or the absolute value of x minus a is strictly between 0 and delta, then the absolute value of f of x minus L must be less than epsilon. But as you have seen, this might be a very daunting task, especially to find the response delta para dun sa challenge epsilon. Luckily for us, we only considered the special cases. We considered a linear function and a couple of quadratic functions last time, pero medyo contrived yung example kasi madali yung preliminary analysis. But for more complicated functions, hindi na natin sila ginagamitan ng epsilon delta para ma-prove na yun talaga yung limit nila. Gumagamit na tayo ng limit theorems. So we will encounter those limit theorems again, but we'll begin with Theorem 3.1, which will kind of tie up the concept of limit of a function with the limit of a sequence. Okay? So ang sinasabi nito ay pwede nating sabihin na yung limit ni f of x as x approaches 0 ay equal kay L using the concept of limit of sequences. So what will happen is this will be true. Statement number 1 will be true if kaya nating ipakita na kahit anong sequence ng mga x sub kahit anong sequence ng mga elements ni A. So you get an arbitrary sequence in A minus x sub 0. So hindi necessarily kasama si x sub 0 dun sa sequence. So pag kumuha tayo ng kahit anong sequence x sub n dun sa set A, such that x sub n converges to x sub 0, and we found out that the limit of the sequence formed by taking the function value of the x sub n's also converge to L, then the limit of f of x as x approaches x sub 0 is also equal to L. So pag kinuha mo yung kahit anong sequence, x1, x2, x3, and so on, tapos ito ay nagko-converge sa x sub 0, kahit anong sequence, alright? Basta nagko-converge siya sa x sub 0, pag binuo mo yung sequence ng mga function values, f of x1, f of x2, f of x3, and so on, hanggang say f of xn, alright? So nakabuo tayo ng bagong sequence. Pag kahit anong sequence ng xn's, nagbigay ng sequence ng mga f of xn's na nagko-converge kay L, then automatically the limit of the function as x approaches x of 0 ought to be equal to L as well. Okay? And you will see later that the utility of this theorem is more of a divergence criterion or the non-existence of a limit. Kasi ang problema rito ay kung gusto mong gamitin itong characterization na to para ma-check kung ang limit talaga ni f of x as x approaches x of 0 ay L, kailangan exhaustively tingnan mo lahat ng sequences kay A na nagko-converge kay x of 0 at tingnan kung yung sequence ng mga function values ay magko-converge kay L. Medyo mahirap yun gawin kasi there could be infinitely many sequences in A that will converge to x of 0, and you should be lucky enough that all of those sequences will produce a sequence of function values that converge to L. Okay? Now, medyo swerte ka kapag nakakuha ka ng dalawang sequences na nagko-converge kay x of 0, pero yung sequence of function values ay nagko-converge sa magkaibang limits. Pag yun yung nangyari, we say that the limit doesn't exist. Okay? What's the advantage of 3.1 then, aside from being a divergence criterion or a non-existence of the limit criterion, ay mapapadali nito yung proofs ng mga limit theorems na ipapakita natin later kasi we can hedge on or we can depend on the results that we have proven for sequences. Makikita nyo na medyo madaya tayo ngayon. Lahat ng theorem na makikita natin for limits, at least the basic ones pala, ay kaya kong i-prove, gagamitin ko lamang si Theorem 3.1 at saka yung mga theorems na na-prove natin mula sa Unit 2. Okay? And the foundation for that is basically Theorem 3.1. Okay? So, but before going there, let's prove Theorem 3.1 first. Kailangan nating kumbinsihin ang mga sarili natin na totoo si Theorem 3.1. So let's try to write the proof of Theorem 3.1. It's an if and only if statement. If we go back to 3.1, it says statement I, if and only if statement 2. So we need to divide our proof into two parts. First, we want to prove statement 1 implies statement 2 and statement 2 implies statement 1 para maging if and only if siya talaga. Okay? Now let's write with the forward implication. So I will assume statement 1. So we will assume that the limit of f of x as x approaches x of 0 is equal to the number L. And for this, we want to show na kahit anong sequence ng xn na nagko-converge kay x of 0 will necessarily imply that the sequence of function values will approach L for any choice of sequence x sub n converging to x sub 0. Ito yung gusto nating ipakita. All right? Now, as usual, kung gusto nating ipakita yon, tapos ang assumption lang natin ay yung pagiging limit ni L nung function f as x approaches 0, then himayin natin ano yung makukuha natin mula dun sa assumption natin that will lead us into the desired to our desired conclusion. All right. So here we can say that what? Okay. But actually here, meron palang additional assumption kasi dito ay assumption natin ay lahat ng sequences dapat ay nagko-converge kay x sub 0. Part yon nung assumption nung property 2. So pwede ko siyang hiramin at mag-consider ako ng sequence x sub n dito. All right? So we will consider any sequence x sub n, okay, from the set A less the limit point x sub 0 such that x sub n converges to x sub 0. So kukuha lang tayo ng isang sequence, an arbitrary sequence ng mga xn's na nagko-converge kay x sub 0. Tapos ang gusto nating ipakita, lahat ng yung sequence of function values ay magko-converge din kay L. Okay? Now, how can we get there? Oh, but here we know that ang limit ni f of x ay equal kay L. Then, for any epsilon greater than 0, we know that there will exist a delta greater than 0 such that if the absolute value of x minus x sub 0 is strictly between 0 and delta, then the absolute value of f of x minus L will be less than epsilon. Okay? So, ito pa lang naman yung obvious na pwede kong magamit, right? Galing dun sa assumption ng limit ni f of x ay equal kay L. Now, the thing is, okay, paano ako pupunta dun sa limit or paano ko mapapakita na yung limit ng mga fxn's ay equal kay L? Okay, so babalik ako dun sa definition ng limit ng sequence from unit 2. Right? So here, ano yung susunod kong pwedeng gawin? So kailangan kong makahanap ng capital N para sa epsilon na given, alright, such that f of x minus L is less than epsilon. Okay? Okay, so here, what else can we use? We can use the fact that the x sub n approaches x sub 0. So alam natin ito ay magiging totoo. This guy will imply this guy, all right, for any choice of epsilon. Basta merong delta na magiging totoo itong inequality na to, right? But I know that the x sub n's approaches, or the x sub n's approach x sub 0. So note that since x sub n converges to x sub 0, then for any delta greater than 0, or actually, I don't want to argue for any delta, then for the given delta, kasi fixed na si delta kanina, right? Ginamit ko na si delta, may nag-exist na delta na totoo ito. Remember, anong definition ng limit ng sequence? For any epsilon greater than 0, there exists a capital N, such that the absolute value of xn minus x sub 0 will be less than delta for all little n greater than or equal to capital N. Alright? Pero pwede kong i-choose or piliin dun sa definition ng limit ng sequence, right? Limit ng sequence xn instead na epsilon, pwede kong piliin si delta to be the boundary there, right? So kasi, or siguro sulat natin, recall, so xn approaches x sub 0 if and only if for all epsilon greater than 0, there exists a capital N in n, such that for all little n greater than or equal to capital N, absolute value of xn minus x sub 0 is less than epsilon. Okay? Totoo daw to sa kahit anong epsilon. Pero dito, sure ako na sa given delta or sa given epsilon, lagi akong may mahanap na delta na totoo itong implication na ito. Alright? Totoo yung implication na yan. Right? So what will happen is, pwede kong gamitin yung delta na to dito sa definition ng convergence ng sequence. So pwede kong palitan ito ng delta for the specific delta. So for delta, for the given delta above greater than 0, we can find a capital N in n, okay, such that for all n greater than or equal to capital N, this inequality is true. All right? So ginamit ko lang na epsilon dun sa limit ng sequence, yung delta na nakuha natin dun sa definition ng limit. Kasi totoo daw to for all epsilon greater than 0, and the delta we have here is greater than 0, then it can qualify as one of the epsilons in the definition of the limit of the sequence xn. All right? Then let me call this implication 1. Alam na natin na si implication 1 ay totoo, right? Kapag ka sure tayo ng x minus x sub 0 ay mas maliit kaysa kay delta, then magpa-follow yung yung inequality involved in epsilon. So thus by 1, it follows that the absolute value of f of x n minus x sub x sub 0 minus what? A minus L is less than epsilon. Okay? So sinabi kasi ni statement 1, ni implication 1, kapag ka si x minus x sub 0 ay may absolute value na mas maliit kaysa kay delta. So pag kinuha ko yung function value ni minuend dito, so nakuha ko si f of x, papalit yung subtrahend ay L, sure ako na less than epsilon yon. So ganun yung ginawa ko dito. Sure ako na si xn minus x of 0 ay may absolute value na mas maliit kay delta. So kunin ko yung function value ng minuend, f of xn, palitan ko yung subtrahend by L, I am sure that the absolute value of that difference will be less than epsilon. Okay? And what do we have here? For any given epsilon greater than 0, we can find a capital N, element of N, such that for all n greater than or equal to n, this inequality is true. And I hope this highlighted phrases will ring a bell. Ito yung definition ng convergence ng sequence f of xn. All right? So here I can say that the limit, or that the sequence of function values converges to L, which proves the first part of the theorem, yung unang implication. Kapag ang limit ni f of x as x approaches x sub 0 ay equal kay L, then ang limit ng sequence of function values ng mga terms ng isang sequence na nag-approach kay x sub 0 ay equal din kay L. Alright? Medyo confusing yung proof kasi meron tayong dalawang limits na pinag-workan dito. But I hope you get the idea. Medyo ginalingan ko lang yung pagpili ng epsilon dun sa definition ng sequence para pumasok siya dun sa definition ng limit ng function f. Alright? Now, are there any questions? May malabo ba doon? Or nag-over-explain na naman ba ako? Okay, everything's clear? All right, I hope it is. If it is not, don't hesitate to ask me any question. I can repeat everything that I said. I don't mind as long as alam ko na gusto nyo talagang intindihin yung mga pinagsasabi ko. Okay? Now, if there are no questions, then let's proceed to the second half. Let's prove the converse. Okay? So conversely, I will assume that for any sequence of xn's from the set A less the set containing x sub 0, all right? Ang alam natin with xn converges to x sub 0, it follows that the sequence of f of xn's converges to L. Ito naman yung assumption. Tapos gusto kong ipakita na yung limit ni f of x as x approaches 0 ay equal kay L. So that's what we want to show. Right? Yan yung gusto kong i-prove. Okay. Now, I'll prove it by contradiction. So I will suppose that the limit of f of x as x approaches x sub 0 is not equal to L. All right? Then my goal is to get a contradiction. Okay? Either I will use this assumption and draw up a contradiction, or I can start from here and show that there is a contradiction to this assumption. So yun yung dalawang pwedeng ruta na puntahan natin. Okay? Siguro gamitin ko muna yung assumption na ang limit ni f of x as x approaches x sub 0 ay hindi equal kay L. So ininegate ko yung epsilon delta definition nung limit. So that means there exists an epsilon greater than 0. Diba sa definition and limit for all epsilon greater than 0, pag ninegate ko siya, merong isang epsilon greater than 0, such that for all delta greater than 0, okay, and then for all delta greater than 0, absolute value of x minus with the absolute value of x minus x of 0 being less than 0 and delta implies that the absolute value of f of x minus L is greater than or equal kay epsilon. Okay? So negation and definition and limit. So may makikita akong isang epsilon greater than 0 na kahit ano pang delta yung piliin ko na greater than 0, as long as x belongs to the delta neighborhood of x of 0, magpa-follow na yung function value f of x minus L ay may absolute value that is greater than or equal to epsilon. Okay? So ngayon, dito ako kukuha ng contradiction. Ano yung pwede kong i-contradict? Pwede kong i-contradict yung nandun sa assumptions natin. Kasi inassume na natin na kahit anong sequence na nagko-converge kay x of 0 ay makakabuo ng sequence of function values na magko-converge dapat kay L. It is assumed to be a fact here. Alright? So a possible contradiction is bumuo ako ng isang sequence na nagko-converge kay x of 0 pero yung function value yung sequence of function values ay hindi magko-converge kay L. And that is sufficient to belie this supposition. And so we can happily conclude that the limit of f of x as x approaches x of 0 ay equal kay L. All right? Let's try to do that. Okay. Okay. Now this is, I can draw up a, okay, meron ako ditong delta. This is for any delta greater than 0. Then probably I can choose or I can take delta to be 1 over n for all n in n. Okay? Sabi nung statement na to, nagwo-work to sa kahit anong delta. So free ako na pumili ng kahit anong value ni delta. So ibig sabihin, pwede akong pumili ng kahit anong delta. So in particular, piliin ko ay si 1 over n para sa lahat ng natural number n. Okay? So that, okay, so yun yung gagamitin ko. And then I will, what? Okay, then we assume that x minus or okay, ano yung pwede kong gawin dito? Bubuo ako ng sequence x sub n. So kailangan kong pumili ng sequence x sub n. But we know that okay. Now we suppose that x sub n is a sequence in A minus x sub 0 that converges to x sub 0. All right? Kasi nga gusto kong i-contradict yung assumption. So kunwari, kukuha ako ng sequence na nagko-converge kay x sub 0. Tapos piliin kong delta ay si 1 over n. Dahil si x sub n ay nagko-converge kay x sub 0, then we can find a capital N in n such that for all n greater than or equal to capital N, yung absolute value ni x sub n minus x sub 0 ay magiging less than 1 over n. Okay? Pwede ko itong gawin kasi alam ko na ang sequence ng mga x sub n ay nagko-converge kay x sub 0. So dahil alam ko na si x sub n ay nagko-converge kay x sub 0, lagi akong makakahanap ng isang element nung sequence na ang layo mula kay x sub n ay less than 1 over n. Okay? And again, because precisely the limit of x sub n as n approaches infinity ay equal kay x sub 0. Okay? Pero ang sabi nitong implication 2, tawagin ko itong implication 2, sabi niya, kapag ka daw ito ay totoo, sa kahit anong delta, then magpa-follow na yung absolute value ng f of the function value of the minuend minus L should be greater than or equal to epsilon. Okay? So sabi nito, kapag ka si x minus x of 0 ay may absolute value na mas maliit kay delta. So ibig sabihin daw, kunin ko yung function value nito, tapos i-minusan ko, minusan ko ng L greater than or equal to epsilon din daw. Okay? So ngayon, kinuha ko to. All right? Then it will follow that this inequality is true. Right? But this is a contradiction. Bakit siya naging contradiction? Contradiction siya kasi alam ko na ang sequence ng mga f of xn's ay laging magko-converge kay L provided yung mga xn's nagko-converge kay 0. And here we have a sequence xn that converges to x sub 0 kasi yung distance nila laging mas maliit sa 1 over n kaya kay x sub 0 for any natural number n. So indeed, x sub n converges to x sub 0, and yet yung sequence ng function values ay hindi nagko-converge kay L. So you can say further that f of xn does not converge to L, which is a contradiction because the xn converge to 0, but yet f of xn does not converge to L. Okay, and that ends the proof. Okay. All right, does the proof make sense, guys? React naman kayo dyan kahit konti. Or medyo malabo ba? Just tell me anong part yung medyo malabo. Or ayaw nyo pa rin mag-respond? Okay, I hope everything is fine. Andyan pa ba kayo? All right, so if there are no questions, then let me proceed to the first corollary. Yung corollary na to ay sinasabi niya lang na ang limit ng isang function at any particular limit point of the domain variable ay unique. So pag meron ka daw function from a to r and x sub 0 is a limit point of a, then the limit of f of x as x approaches x sub 0 is unique. Paano natin ito ma-prove? Nandiyan naman yung actual proof, pero ano yung idea behind the actual proof? So you can read the actual proof later, pero ganito yung idea. So i-suppose natin na may dalawang limit. Ang limit ng f of x as x approaches x sub 0 ay equal kay L1 at saka kay L2. Okay? Kunwari lang. Dalawa yung limit na na-compute natin. Alright? Then from Theorem 3.1, ibig sabihin, I can find a sequence, okay? I can, for any sequence of xn's that converges to x sub 0, we will have a sequence of function values that converge to L1 and a sequence of function values that converge to L2 as well. Okay? Pero ang sabi ng Theorem 3.1, kapag kahit anong sequence na nagko-converge kay x sub 0, yung limit, yung sequence of function values dapat magko-converge kay L1. Okay? So ibig sabihin, kung magko-converge to kay L1, dapat si L1 ay equal kay L2. At si L2 dapat equal din kay L1. Because we have here two sequences, or actually the same sequences, all right? Kumuha ako ng isang sequence ng mga xn na nagko-converge kay x sub 0. Isang sequence lang. I-apply ko si Theorem 3.1 with assumption that the limit is equal to L1, if and only if kasi si Theorem 3.1. So kung ang limit ni f ay equal kay L1, then yung limit ng f of xn dapat equal din kay L1. Alright? Tapos, limit din daw niya si L2. So pag in-apply ko ulit si Theorem 3.1, doon sa parehong sequence xn's at kinuha ko yung function values niya, dapat yung sequence ng function values nag-approach din sa L2. Pero ano ang alam natin sa limit ng sequences? Na-prove na natin before that the limit of a sequence is unique. And yet here, we have one sequence, the sequence of f of xn's, that converge or that seemingly converge to two numbers, L1 and L2. And by that theorem that we learned from limit of sequences, it is necessary that L1 is equal to L2. So ibig sabihin, dapat unique yung limit ng isang function at a given limit point. All right? And hopefully that will serve as a template on how to prove corollary 3.2, which are all algebraic limit theorems for functional limits. So ito ay extension ng mga results nyo from Math 36. Pero siguro pinrove nyo rin to sa Math 36 pero ang ginamit nyo yung definition. Binigyan kayo ng epsilon, naghanap kayo ng delta. Pero the development we have in Math 155 allows us to take advantage of the limit theorems for sequences para ma-prove itong mga limit theorems para sa limit ng functions. So for instance, ano yung pwede natin gawin? Siguro try natin yung corollary I. Okay. Informal ko na lang din siya isusulat. You can try to write a formal proof for yourself. So gusto natin kunin, i-prove na yung limit ng f of x o limit ng k f of x as x approaches x sub 0 ay equal kay kl, where k is a constant and l is the limit of f of x. Okay? So ang gagawin ko ngayon, I will take any sequence. Dahil alam ko na limit ni f of x ay equal kay l as x approaches x sub 0, then for any sequence x sub n from the set A less the set containing x sub 0, okay, such that, or with the property that xn approaches x sub 0, we have the limit of, or the limit of the sequence of function values is equal to L. All right? And then that means that kung yung limit ng mga f of xn ay nagko-converge kay L, by one of the previous theorems we prove, or one of the algebraic theorems for the limit of sequences, we also know that the sequence of k f of xn will converge to k times L, right? So ang reason dito ay yung algebraic theorems for the limit of a sequence. Pag meron kang sequence, minultiply mo by a constant lahat ng terms ng sequence, ang limit niya ay yung same constant times the limit of the original sequence. Okay? And then now, I will again invoke proper Theorem 3.1. Sabi ng Theorem 3.1, kapag sa kahit anong sequence na nagko-converge kay x sub 0, yung sequence of function values ay nag-converge dun sa limit na o dun sa number na k times L, dapat yung limit ng function as a function of the a function in the given domain, dapat ang limit niya ay equal dun sa common limit ng mga sequences. So therefore, I can say here that the limit of the given function, which is k times the function f of x as x approaches x sub 0 ay equal lamang kay k times L din. Okay? By Theorem 3.1. Okay? And that ends the proof. Pagandahin nyo na lang yung pagkakasulat, pero yung backbone ng proof ay eto na. Okay? So basically, nakihitch lang tayo dun sa algebraic limit theorems for sequences gamit ang pamasahe lang natin sa pag-hitch na yon ay si Theorem 3.1. Okay? And you can do that for the rest of the statements in this corollary. Okay? Yun yung kagandahan dun sa development. Nag-start tayo sa limit ng sequences, madali na tuloy ngayon yung mga proof ng mga limit theorems. Okay? Questions, guys? Nandyan pa ba kayo? Pagalawin nyo nga ang mga reaction buttons nyo kung andyan pa kayo. Grabe, wala talagang Ayun, finally. Thank you, CK and Adriel. Okay, now let's continue. Kung clear yung mga theorems so far, so na-inherit niya yung algebraic theorems for sequences papunta sa functions. Tingnan naman natin yung kinikwento ko kanina na practicality or utility ng theorem 3.1. Okay? So it says here that we can use a version or we can use a consequence of theorem 3.1 to prove that the limit does not exist. And it says here basically that, of course, the usual preamble, pag meron kang function f defined on a set A for which x sub 0 is a limit point, okay? Pag nakakita tayo ng at least dalawang sequences, say xn at saka yn, na yung mga xn's at mgayn's ay never naging equal kay x sub 0, alright? Tapos, yung limit ni xn at saka ni yn ay parehas equal kay x sub 0. So dalawang magkaibang sequences na parehas yung limit na si x sub 0, pero yung limit ng function values nila ay magkaiba, then the limit does not exist. So you can think of it as a sort of a generalization nung natutunan natin sa Math 36, na yung limit from the left ay hindi equals the limit from the right, then the limit doesn't exist. Ito medyo mas general siya. So it doesn't matter if you're going from the left or going from the right, as long as you can find a sequence going to x sub 0 or two sequences going to x sub 0, but giving us different limits of sequences of function values, then the limit of the function will not exist as x approaches x sub 0. Okay? Para hindi na natin kailangang ipakita na may nag-exist na epsilon such that for all delta greater than 0, then we'll have that negation of the definition of the limit. Okay? Pwede kang mag-hunting ng dalawang sequences na nagko-converge kay xn na magkaiba yung limit ng sequence ng function values. Okay? And this would be a nice way to prove that the limit of sine of 1 over x as x approaches 0 does not exist. Okay? So again, ang goal natin, makahanap ng dalawang sequences na parehas nagko-converge kay 0. Okay? Kasi yung limit point natin na ginagamit para sa variable x ay si 0. So dalawang sequences na nagko-converge kay 0 na yung sequence ng function values ay magkaiba yung limit. Okay? And the example here gave us such two sequences. So unang example, sequence ng 1 over 2 pi n. Okay? So when n increases, habang palaki ng palaki si n, yung 1 over 2 pi n ay papunta sa 0. So definitely here, the limit of xn is equal to 0. Or we say that 1 over 2n pi converges to 0. In the same manner, pag tinignan naman natin si yn. Okay? Si yn, ito daw yung itsura, 1 over 2n pi plus pi over 2. Definitely, xn is not equal to yn. Kasi kahit kunin mo yung n equals 1, magkaiba na sila ng first term. Pag merong terms na magkaiba dun sa sequence, sa dalawang sequences, hindi na sila equal sa isa't isa. Or kung may majumble dun sa dalawang sequences, hindi na rin sila equal sa isa't isa. So you can plug in n equals 1 here, plug in n equals 1 here, you get two different values, so they differ in the first term. Automatically, si xn ay kakaiba mula dun sa sequence ng mga yn's. But the thing is, they both converge to 0. Kasi kapag si n ay palaki ng palaki, yung 2n pi is a huge number, dagdagan mo pa ng pi over 2, that's an even larger number. 1 over a large number will go to 0. So si y sub n, ang limit niya rin ay si 0. Okay? Pero ito yung maganda sa dalawang sequences na to. Kunin ko yung function value ng mga xn. So compute natin yung f of x sub n. But our x sub n here is 1 over 2n pi. Okay? Tingnan natin kung ano yung makukuha nating sagot dito. Alright? So pag kinuha ko to, magiging sine of 1 over x sub n. Ang x sub n natin ay ito. So ito ay magiging 1 over 2n pi. Okay? So yung x, pinalitan ko ng xn. So kaya naging ganyan siya. Simplifying the argument of sine, this will be 2n pi. Okay? Tapos ano ang sign ng even multiples ni pi? Even multiples ni pi, laging 0 yung sign. Okay? So that means the sequence of function values emanating from the x sub n's ay constant sequence lamang. Puro zeros yung mga f of x sub n's. So therefore, since it is a constant sequence, yung sequence ng f of x n's ay magko-converge kay 0. Okay? Now, tingnan naman natin yung sequence of function values coming from the y-ends. So, kunin natin yung sign ng 1 over yn. So, kakaroon tayo ng 1 over 2n pi plus pi over 2. Equal lang to sa sign ng 2n pi plus pi over 2. So, basically, ito ay sign ng sign ng mga pi over 2 or mga certain revolutions of pi over 2, right? Kasi kapag ganito lang yung itsura niya, nandito lagi tayo sa mga 2n pi, mga multiples ni 2 pi. Magdadagdag lang tayo ng pi over 2. Dito pala, sorry. So ito yung pi over 2. Yung sign ng pi over 2 ay laging equal kay 1. Okay? So that means f of y sub n converges to 1. And what we have here are two different sequences. Both of them converges to the number 0, and yet the sequence of function values converge to two different numbers. So by corollary 3.3, it follows that the limit of sine 1 over x does not exist. Okay? Any questions? Of course, you could have given me a different xn and a different yn. I don't care. So dapat ang requirement lang si x sub n at saka si y sub n parehas nagko-converge kay x sub 0, which is 0 in this case. Pero yung sequence of function values ay magkaiba yung limit. Okay? Okay. Medyo kinakabahan ako kasi ang tahimik nyo, guys. Perhaps for this, I can get a volunteer. Let's go back to the problem of Dirichlet, or the function defined by Dirichlet. Si f of x ay equal kay 1 if x is rational, 0 if x is irrational. Okay? Then can somebody prove to me that the limit doesn't exist? The limit of f of x as x approaches say as x approaches say 1/2 does not exist. Okay, can anybody sige, padaliin na lang natin. 0 na lang yung limit. Yung limit point. So, any idea paano ko ipo-prove na hindi nag-exist yung limit nitong function na to as x approaches 0? Okay, any volunteer? Or magtatawag na ba ako? So, kailangan yung umimbento ng sequence na nagko-converge kay 0 na magkaiba yung sequence of function values. Sige, kahit hindi nyo ma-construct, any idea? Tulungan nyo lang ako. Paano ko siya ma-prove? Sige na nga, magtatawag na lang ako. Bawal lumabas ng meeting. At bawal gamitin ang pinagbabawal na technique na biglang madi-disconnect. So, let me see. Random. Ray. Any idea? Can you help me out? Ano kaya yung pwede kong gawin? Kahit suggestion lang kung ano yung next step. Kung hindi nyo pa alam yung actual answer.
Ano po, kumuha po ng element po ng f of x, tapos ipakita po na ano, hindi ko po sure, pero kumuha po ng dalawang element ng f of x na ang limit po ay magkaiba.
Okay. Yeah, thank you, Ray. That's a nice idea. So I think what you meant is kumuha ng dalawang sequences ng mga function values na magkaiba yung limit. Tama? Pero ang requirement dapat muna yung ilalagay natin ng mga x sub n dun sa loob ng functions ay isang sequence na nagko-converge kay 0. Okay? Thank you, Ray. Anybody else? So yun yung strategy. Susundin natin yung strategy ni Ray. So what can I do next? Sige, let's see. CK, do you have any suggestion? So paano ko magagawa yung suggestion ni Ray?
Sir, yung sa sin 1 over x po ba yan, sir? Ay yung sa taas para 1.
Hindi na.
Yan
Dito
pala.
na sa Dirichlet function. Yeah. Paano ko mapapakita na yung limit ay hindi nag-exist? Suggestion ni Ray, humanap ng dalawang sequence of function values na magkaiba yung limit. Pero can you help me out get those sequence of function values? Medyo kailangan nating maging konting creative dito kasi dalawa lang yung posibleng function values, right? It's either 1 or 0. So kailangan kong kumuha ng dalawang sequence. Sige, bibigay ko yung unang sequence. Sige, kukunin ko yung mas madali. Consider ko si xn to be the sequence of 1 over n's. Okay? And obviously, yung sequence ng mga 1 over n ay nagko-converge kay 0. Alright? And then here, x sub n, or all of the x sub n's ay element ni q. Lahat ng 1 over n ay rational kasi si n naman ay natural number. So that means x sub n is in q. So therefore, f of xn ay nagko-converge kay 0. Kasi, nagko-converge kay 1. Okay? So again, ang ginawa ko rito, kinonstruct ko yung sequence ng mga 1 over n's. Alam ko yung mga 1 over n's nagko-converge kay 0, which is the limit point na kinoconsider natin. Okay. Tapos, inonote ko na yung mga 1 over n ay laging rational. So pag kinuha ko yung function value ng mga 1 over n's, laging equal kay 1. So what I get as a sequence of function values ay isang constant sequence na puro ones yung laman. Sorry. And so automatically, the limit of the sequence f of xn ay equal kay 1. Okay? Now, to satisfy Ray's suggestion kanina, kailangan ko pang makahanap ng isang sequence na nagko-converge din kay 0, pero yung function values nila ay hindi magko-converge kay 1. Posibleng may ibang path o ibang number kung saan siya nagko-converge. Can anybody give me such an example of a sequence?
Sir, 1 over square root of n ba, sir?
Okay. So y sub n equals 1 over square root of n. All right, magko-converge yan kay 0, tama? Pero sure ba tayo na, so anong susunod kong masasabi out of this? So posible siyang candidate sequence. So kailangan kong tingnan ngayon ano yung limit ng sequence of function values.
0 and 1 po, sir. Kasi kung perfect n, magiging rational siya. Pero kung hindi perfect square yung n po, hindi siya rational.
Okay. Thank you, CK. Yeah, actually, I could have gone through with CK's example right away, and I wouldn't need this guy. All right. So, kasi sufficient yung example ni CK kasi tama siya. So, yung 1 over square root of n ay magko-converge kay 0. Pero si 1 over square root of n, minsan siya ay rational. Nangyayari siya kapag perfect square si n. At irrational naman siya kapag hindi perfect square si n. So, ibig sabihin, f of yn ay hindi nagko-converge. Kasi minsan siya ay 0, minsan siya ay 1. Hindi natin alam yung mangyayari in the long run. So, thank you, CK. That's one example fits all. That's fine. Okay? So, yeah, pwede siyang gawin. Or, pwede rin naman. So, this sequence f of yn, dahil nga minsan si yn ay rational, minsan siya ay irrational, does not converge. At dahil hindi siya nag-converge, then automatically by Theorem 3.1, si f of x ay walang limit as x approaches 0. Okay? Or kung pwede namang hindi yn yung ibigay nyo. Halimbawa, ibigay ko na lang ay si zn, tapos si zn ay pi over square root of n. Wag palang square root of n. Sabihin ko na lang siya ay say pi over n. Okay? So si pi ay irrational, si n ay rational, irrational divided by rational ay always irrational. Pero itong mga zn's, magko-converge pa rin siya kay 0. Okay? And then all of the zn's are irrational. Therefore, ang f of zn ay equal kay 0 for all n. All right? So in other words, f of zn converges to 0. And I have here a sequence of function values converging to 0. And we have found earlier a sequence of function values converging to 1, 2 different values, then by corollary 3.3, or corollary 3.3, the limit does not exist. All right? Pero mas maganda nga yata yung example ni CK, posibleng ano na siya. Ito na lang yung ibigay ko kasi hindi siya nagko-converge. Pero ang i-invoke ko doon ay mismong Theorem 3.1. Yung negation, yung converse, yung contrapositive ng isang side ng Theorem 3.1. All right? There's a bunch of exercises here that you can try. Of note here would be the squeeze theorem for limits. So totoo pa rin yung squeeze theorem para sa limits. And again, the proof of that will just be hinged on invoking Theorem 3.1 and the squeeze theorem for sequences. Okay? Pero I'll just mention that na, okay, assume natin na na-prove nyo si squeeze theorem. Kasi may mga theorem siguro later na kakailanganin ko yung squeeze theorem. Pero again, ang extension niya ay katulad lamang nung proof natin sa corollary, proof natin ng corollary 3.1 at saka corollary 3.2 statement 1. Ganito lang yung magiging template. Babalik lang ako dun sa mga theorems para sa sequences, tapos gagamitin ko si Theorem 3.1 para i-translate siya sa limit ng function. Okay? But from now on, you can use the squeeze theorem for functions. I-assume ko na na-prove na natin siya. Okay? But it would be a nice exercise if you can try to write the proof of the squeeze theorem. Okay? Let's move further. Tapos basahin lang natin mabilis. Ito ay dinagdag ko nung over the weekend dun sa Unit 3 lecture notes so that we can talk about one-sided limits. Okay. Now we consider a real number x of 0 and a delta greater than 0. Tapos i-define natin kung kailan nagiging left limit point ni A si x of 0 at kailan siya nagiging right limit point. what we know before is the definition of a limit point. Okay? Sabi natin, limit point si x kapag kahit anong epsilon neighborhood centered at x sub 0, pag kinuha ko yung intersection with a minus x sub 0, dapat ito ay non-empty para siya maging limit point. Bawat epsilon neighborhood around x sub 0 will contain another member of a except possibly x sub 0. Okay? Ngayon, medyo ipaliitin natin siya ng konti. Kunin natin yung pagiging right at saka left limit point. Remember dito yung epsilon neighborhood, ang ibig sabihin niya ay open interval x sub 0 minus epsilon and x sub 0 plus epsilon. Yun yung epsilon neighborhood. Okay? Now, nag-define ako dito ng left neighborhood saka right neighborhood. So yung b minus delta, ito yung left delta neighborhood ni x sub 0, papunta lang ako sa kaliwa. So kunin ko yung interval, x sub 0 minus delta until x sub 0. Okay? And then, yung right neighborhood, b plus delta, okay? Siya naman yung mula kay x sub 0 hanggang kay x sub 0 plus delta. So pwede niyong isipin na itong mga open balls na to, itong mga open intervals na to, ay parang partition lamang nung epsilon neighborhood ni x sub 0. Pero nawala si x sub 0 sa kanilang dalawa. So bale, instead na epsilon neighborhood na nakagitna kay x sub 0, si x sub 0 gagawin kong subdivision point. Yung left neighborhood ay mula kay x sub 0 hanggang kay x sub 0. Mula kay x sub 0 minus epsilon hanggang kay x sub 0. Tapos yung right epsilon neighborhood ay mula kay x sub 0 hanggang kay x sub 0 plus epsilon. Pero sila ay mga open balls, mga open sets itong mga neighborhoods. So kaya gusto ko sila ay maging open intervals. Kaya hindi ko sinasama si x sub 0. Okay, hindi kasama si x sub 0, hindi kasama si x sub 0. Kasi pag sinama ko si x sub 0, ginawa ko itong close sa kaliwa, close sa kanan, tapos ito ay close sa kaliwa, hindi na siya magiging open set. Okay? So yan yung left at saka right neighborhood of x sub 0 with radius delta or with length delta. Okay? Now, tapos gagamitin ko lang tong mga left at saka right neighborhoods para ma-define yung left at saka right limit point. So here we say that x sub 0 is a left limit point of A if kahit anong delta ang piliin ko. Tapos i-consider ko yung left delta neighborhood. So i-consider ko yung b minus delta of x sub 0, yung intersection niya with A minus x sub 0 ay hindi empty. Actually, pwede na nga nating tanggalin dito si x sub 0. Kasi si x sub 0 naman, imposible na nandun sa intersection. Kasi si x sub 0 hindi nagbe-belong sa b delta minus. Okay? So pag kinuha ko yung intersection ng b delta minus neighborhood, at saka ni A, siya ay non-empty sa kahit na anong delta, ibig sabihin left limit point ni A si x sub 0. So in other words, nagkukumpulan yung mga elements ni A mula sa kaliwa papunta kay x sub 0. Alright? So kung ito si x sub 0, okay, ibig sabihin nagka-cluster o nag-accumulate yung mga elements ni A mula sa kaliwa ni x sub 0. So posibleng ito yung mga members ni A. Member ni A, member ni A, member ni A. Okay? And then, lagi silang magka-cluster papunta doon kay x sub 0. Alright? So, ibig sabihin, kahit gaano pa ako kalapit kay x sub 0 mula sa kaliwa, laging merong element ni A, yung b delta minus neighborhood ni x sub 0. Okay? Pero posible rin naman na marami ring elements ni A sa kanan. Pero sa pagiging left limit point, ang kino-consider ko lang ay yung accumulation ng mga elements ni A mula sa kaliwa ni x sub 0. Okay? So ang idea nito in layman's term, nagkukumpulan yung mga elements ni A sa kaliwa ni x sub 0 kasi kahit humakbang lang ako ng napakaliit pakaliwa mula kay x sub 0, lagi akong may makakasalubong na element ni A. Tapos ganun din yung right limit point. Pag naglakad ako ng konti mula pakanan, mula kay x sub 0, lagi akong may makakasalubong na element ni set A. Kasi nga, right limit point si x sub 0, ibig sabihin, nagkukumpulan sa kanan niya yung mga elements ni A. Alright? And then with this idea of left and right limit points, oh, by the way, if x sub 0 is both a left limit point and a right limit point of A, then x sub 0 is a limit point of A. Actually, hold on. Tama ba yung statement na yun? Yes, totoo siya. Pero actually, merong mas generic. Totoo ba na kapag ka siya ay left limit point, automatic na siya ay limit point kaagad? Can anyone argue or reason out? Totoo ba yun? Pag siya ay left limit point, automatic ba na limit point na siya kaagad? Kasi sure ako kapag ka limit point siya, automatic siya ay left limit point at saka right limit point. Pero yung pakabila ba? Kung siya ay left limit point, automatic ba na siya ay limit point din? Bigla ko napaisip eh. Let me see. What do you think? Sige, Rexter. Ano sa tingin mo? Kahit hula lang.
Sir, feeling ko po hindi. Kasi pwede pong piecewise defined yung sequence. Tapos pwedeng hati.
Pwedeng hati? Pero ang assumption ko left limit point siya muna. So for you, mukhang hindi.
Okay. Apo.
Okay, let's see. How about the others? Thank you, Rexter. Denmark, what do you think? Kapag ka left limit point ba, automatic siya ay limit point din?
Hello po. Tingin ko po limit point din po siya.
Bakit mo naman nasabi?
Kasi po pag po nag-construct po ng epsilon neighborhood mula po sa x sub 0, meron na din pong element doon po sa delta neighborhood to the left po ng x sub 0.
Okay, thank you, Denmark. Yeah, that's correct. Pero nice try, Rexter. Pero siguro mas maniniwala ako kay Denmark for now. Kapag ka siya ay left limit point, siya ay limit point na rin kaagad. Bakit? Kasi ang requirement natin sa pagiging limit point, diba dapat si x sub 0, kahit anong epsilon neighborhood, full epsilon neighborhood centered at x sub 0, dapat may laman na element ni A. So, kukuha ko dito, kahit anong epsilon neighborhood yan, dapat siya ay may laman na element ni A. Alright? That's what it takes to be a limit point. Pero, kung siya ay halimbawa right limit point, so, kung siya ay left limit point, tapos magro-drawing ako ng isang epsilon neighborhood, or pipili ako ng isang epsilon neighborhood. So, halimbawa, ito yung epsilon neighborhood na i-consider ko. Okay? So, wala man siyang element dun sa kanan, alright? Kasi hindi naman siya right limit point. So, posibleng walang element si capital A mula sa kanan ni x sub 0 o malapit sa kanan ni x sub 0. Pero the fact that x sub 0 is a left limit point of A guarantees na, di ba, pag umusong ako ng kaunti pakaliwa, may makakasalubong ako na element ni element ng delta neighborhood. So dito pwede nyo isipin na yung delta would be what? Actually, delta is also the epsilon value, right? Dun sa definition natin nung b sub delta minus saka b sub delta plus, okay? So pero yung idea ay wala man ako makakasalubong na element ni A dun sa kanan ni x sub 0, pero dahil left limit point siya, dun sa kaliwa ni x sub 0, laging may present na element ni A. So kung pala siya ay left limit point, automatically isa na siyang limit point. Kasi nga ang mangyayari ay yung element na makikita ko sa kaliwa, siya rin yung gagamitin kong element ng epsilon neighborhood para dun sa definition ng actual limit point. Okay? So medyo misnomer nga nung kanina nga nung binabasa ko yung definition, netong nagdi-discuss tayo. Parang gusto kong sabihin na kapag ka siya ay left limit point, hindi siya automatically limit point. Na kailangan sabay siya maging left at saka right limit point. Pero upon upon thinking about it a little further, I caught myself and mukhang pagka left limit point siya, automatic na siya ay limit point. And I guess I'll agree with Denmark na totoo yun. Okay? So mas restrictive yung pagiging left limit point ng isang set. Kasi required na nasa kaliwa yung nasa kaliwa yung makukuha mong member ni A. Ang mali pala yung una kong sinabi. Ano yung una kong sinabi? Kapag ka siya ay So kapag ka siya ay left limit point, automatically limit point na siya. Pero pag limit point ba siya, automatic ba na left limit point siya? Siguro yun yung binabanggit kanina ni Rexter na kapag ikaw ay isang limit point, hindi ka necessarily isang left limit point. Tama ba? Kasi kung limit point ka, pwedeng yung mga pwedeng tama nga si Rexter, pwedeng parang piecewise yung pagkaka-define ng sequence, naging limit point ka, pero yung mga elements ni A laging nasa kaliwa, nasa kanan mo halimbawa. So halimbawa ito si x sub 0. Kunwari x sub 0 is a limit point of A. So nasa derived set siya ni A. Pero posible na yung mga elements ni A ay nagkukumpulan mula sa kanan ni x sub 0. Okay? So kasi sufficient 'yon na kapag ka ikaw ay limit point, ang kailangan ko lang ay sa bawat epsilon neighborhood kailangan merong element ni A. Pero paano kapag ka lahat ng element ni A ay nasa kanan ni x sub 0? So imposible na si x sub 0 ay maging left limit point ni A. Kasi wala akong makakasalubong na elements ni capital A pag nag-travel ako pakaliwa. Pero limit point siya kasi yung epsilon neighborhood, pwedeng kumuha ako mula sa kaliwa or pwede sa kanan, limit point na siya. Pero mas restrictive yung pagiging left limit point o pagiging right limit point kasi dinidikta nila kung saang direction dapat nag-exist yung arbitrarily close elements of the set A. Okay? So please erase what I said earlier. So kapag ka siya ay left limit point, automatic limit point. Kapag ka siya ay right limit point, automatic siya ay limit point. Pero pagka siya ay limit point, posibleng hindi siya left limit point, posibleng hindi siya right limit point. Do you guys agree with that? Mas okay talaga siyang i-analyze kapag ka may drawing na kasama. Okay, wala bang violent reactions? So siguro yun yung binabanggit mo nga, Rexter, kanina. Medyo naguluhan din ako dun sa pagkaka-state ko ng question. Pero yeah, I guess that settles it. All right. Okay. Now, with that in mind, we are now allowed to define one-sided limits. Okay. Now, we consider a function f defined on a subset A of R towards the set of real numbers, and we let x sub 0 be a left limit point of A. And if that is the case, then we can define the limit of f of x as x approaches x sub 0 from the left. Okay? Yung superscript na minus sign that denotes that pupunta ako mula sa kaliwa ni x sub 0. At yun yung dahilan kung bakit left limit point dapat si x sub 0. Dapat pwede akong makarating kay x sub 0 through a sequence of elements of A na nanggagaling mula sa kaliwa ni x sub 0. And if that's the case, then I can say that the left limit of f as x approaches x sub 0 ay equal kay L if and only for all epsilon greater than 0, I can always find a delta greater than 0 such that ang absolute value ng f of x minus L ay less than epsilon sa lahat ng x na member ng left delta neighborhood ni x sub 0. Siguro mas magandang tawag yun. No? Tawagin na lang natin to kasi it's quite a mouthful if we will read this literally. Let's just call this the left delta neighborhood of x sub 0. Okay? So meaning if x belongs to the left delta neighborhood of x sub 0, then that means f of x minus L must necessarily be less than epsilon. Or pwede nyo itong i-translate as absolute value of, hindi na pala absolute value, pwede ng x minus x sub 0, pero si x ay nasa kaliwa, so dapat ito dapat ay less than delta. Tama? Si x kasi nasa kaliwa ni x sub 0, baligtad. Si x ay nasa kaliwa ni x sub 0, so dapat ito ay x sub 0 minus x must be less than delta. Kasi si x nagbe-belong sa left delta neighborhood, so mas maliit si x kaysa kay x sub 0, pero si delta ay positive, so dapat ang x sub 0 minus x ay mas maliit kay delta. Okay? And that is the left-hand limit of x sub 0. And a similar definition can be made kapag gusto naman natin yung right-hand limit. So ang restriction dito, dapat si x sub 0 ay isang right limit point. So here, x sub 0 must be a right limit point of A. And then dapat, if x sub, or if x minus x sub 0 is less than delta, meaning x belongs to the right delta neighborhood of x sub 0, then it should follow that the absolute value of f of x minus L is less than epsilon. Parang nahati lamang yung definition ng actual limit, right? Kasi di ba dun sa definition ng limit, dapat yung absolute value ng x minus x sub 0 ay less than delta. Pero may posibleng dalawang cases. Yung x sub 0 minus x ay positive o yung x minus x sub 0 ay positive. Okay? Kasi yung absolute value of x minus x sub 0, pwedeng either ito or pwedeng ito. So, pinaghiwalay natin siya na kapag ka ito yung totoo, dapat itong inequality na to ay totoo rin, then we have a left-hand limit. And the other way around for the right-hand limit. Okay? Pero ito pa rin yung konsepto o ito yung generalization ng konsepto ng one-sided limits sa Math 36. And maybe I can give Theorem 3.2 and we can stop here. So we can consider, or we have this theorem, which is another characteristic or another way to check whether the limit of a function exists or not. So if you have a function f from a to r, and suppose x sub 0 is both a left limit point and a right limit point of a, then the limit of f of x as x approaches 0, or as x approaches x sub 0 is equal to L, if and only if the left-hand limit and the right-hand limit agree with each other. Okay? So dapat maging equal yung left-hand at saka right-hand limit para maging yung limit ni f, para mag-exist yung limit ni f of x as x approaches x sub 0. Okay? Pero be careful with this. Okay? Dapat mag-hold lang tong theorem kung si x sub 0 ay parehas na left limit point at saka right limit point ni A. Alright? So, medyo ito siguro yung kaibahan mula dun sa Math 36. Kasi sinabi natin na pag hindi nag-exist yung isa dun sa dalawang one-sided limits, automatically the limit doesn't exist. Pero itong Theorem 3.2, sinasabi niya lang na dapat, para mag-apply ito, dapat si x sub 0 ay parehas na left limit point at saka right limit point ni A. Okay, pag meron siyang hindi na-satisfy dito, kapag ka left limit point lang siya pero hindi siya right limit point, hindi mag-a-apply yung theorem. Okay? And this will be true, say, for the square root of x. So ang domain niya lamang ay 0 to positive infinity. Okay? So, si 0 ay hindi siya left limit point ng domain. Okay? Kasi walang element ni domain na nasa kaliwa ni 0. So, ibig sabihin, hindi siya limit point ni, hindi siya left limit point ng domain. So, ibig sabihin, hindi mag-a-apply yung Theorem 3.2 sa kanya. Pero sinabi natin dati sa Math 36 na yung limit ng f of x as x approaches 0 does not exist. Kasi hindi nag-exist yung limit from the left. Pero ngayon, sa Math 155, dun sa pagkaka-define natin ng limit, kailangan limit point siya. Eh si 0 naman, limit point siya ng domain. Tama? Kasi pag nag-drawing ka ng kahit anong epsilon neighborhood, centered at 0, lagi tayong may mahanap na element ng domain doon sa epsilon neighborhood na yon. Yun nga lang, puro nasa kanan yung makikita natin na element ng domain. Alright? Which is fine kasi kung siya ay right limit point pa rin siya. So yung limit nito ay mag-exist in the sense of Math 155 as x approaches x sub 0. So we can say here that the limit is equal to 0 as x approaches 0. Okay? Kasi nga, with respect to this domain, yung pagkuha natin ng limit. Tapos, hindi nag-exist yung limit niya mula sa kaliwa kasi hindi left limit point si 0 nung domain. Pero yung Theorem 3.2 is carefully stated so as to only apply whenever the number x of 0 is both a left limit point and a right limit point. At dahil si 0 ay hindi naman left limit point, so I don't care if the limit of f of x as x approaches x of 0 from the left doesn't exist. Kasi hindi naman mag-a-apply si Theorem 3.2 kasi hindi naman left limit point si 0. So there is no sense in talking about the limit from the left. Okay? Pero yung limit nag-exist kahit hindi nag-exist yung limit mula sa kaliwa. Kasi nga, ang usapan, limit point lang siya dapat nung domain na si 0 to positive infinity. Okay? So yun yung medyo counting technical difference with the Math 36 definition. Actually, as I think I have mentioned this, medyo misnomer yung sinabi natin sa 36 na kapag yung function ay hindi defined sa isang open interval containing centered at x sub 0, then sinasabi natin dati na limit doesn't exist. But the technical statement there, o yung tamang implication nun ay hindi nag-a-apply yung definition. Kasi hindi siya defined sa isang open interval containing the number x sub 0. Okay? So hindi natin pwedeng gamitin yung definition na yon. But in Math 36, unfortunately, we didn't bother to define what will happen if f is not defined in some open interval containing x sub 0 except possibly at x sub 0. Nandito pa sa Math 155 kung kailan natin pinunan yung loophole na yon sa Math 36 definition. Okay? So medyo magkaiba yung konsepto ng left-hand limit at saka right-hand limit with that aspect. Kasi now we can talk about more complicated domains. Okay? Not necessarily containing an open interval for which the function is defined everywhere. Okay? Now, I guess that would be it. Hopefully, medyo masanay kayo sa math, sa kaibahan niya mula sa Math 36 because next time we'll be talking about continuity. All right? Ano naman yung konsepto ng continuity in a more general sense than what we have seen in Math 36. All right? So, do you guys have any questions? Oh, by the way, may nabigay na ba ako na homework about limits o wala pa? Gusto niyo na ba mag-homework or next week na lang ako magbibigay? Next week na lang, no? Para week after next pa yung deadline. So para medyo adjust muna kayo after the reading break. And I understand some of your classes might have moved the deadline for submission of requirements that they gave you before the reading break na force sila na i-move ito next week. So para hindi sumaba yung homework natin, ibibigay ko na lang yung una nating homework after the reading break on probably on Tuesday. Tapos ang deadline niya ay Monday week after next. All right? So, is that okay with you guys? Or gusto nyong umapilan ng konti? Sabihan nyo lang sa akin pag medyo nabibigatan kayo, so I'll try to make your life easier. Ako na lang yung mag-sacrifice kung hindi nyo mapakiusapan yung iba nyong math instructors or instructors with other subjects. Okay. All right. So if there are no questions, then thank you guys for coming today. I hope you have a good night. And then, as always, let's see each other again on Tuesday. Bye, everyone.